All right, hello y'all. Let's get started with this practice test. Just going through all the problems. Starting with number one, what is the maximum number of electrons in energy level n equals 3? Well, energy level 3 has the 3s, the 3p, and the 3d. And so in each of these energy levels, we have to consider the number of electrons. So each orbital holds 2 electrons, but there is only one s orbital. There are 3 p orbitals and 5 d orbitals. So that's 2 plus 6 plus 10. That's a total of 18. So for this answer, we get 18. So the correct answer for number one is B. All right, moving on to number two. What is the electron configuration for an element in group 2, period 5? Well, I have my periodic table here. Group 2 is this vertical column. Period 5 is this horizontal row, so strontium. So looking backwards, we are at krypton. So we're going to be krypton, and then 5s, and then spot 1, spot 2, 5s2. So we're looking at A, krypton, 5s2. Moving on to number 3, naturally occurring sulfur consists of the isotopes S31 and S33. What is the approximate percent abundance of 31s? So there's the real mathematical way to do this, which is the total abundance, x plus y, is equal to 100%, like the total abundance of each one, where x can represent 31, y can represent 33. Then you can kind of change this around and say y is equal to 100 minus x. Therefore, the percent of 31s plus the percent of 33s will equal our total mass of 31.5. So we could do it this way, and then we get x times 31, representing the mass of sulfur 31, plus 100 minus x, representing the percent abundance of sulfur 33, is equal to 31.5. And that'll tell us that x is equal to 75. I have an issue with this one. And by the way, it would be 75%. And we'd have to account for percentages. So instead of 100%, you would really actually have to say 1, but that is the mathematical technicalities. There's a much easier way to do this problem, which really is just, if you have a mass of 31 and you have a mass of 33, and we look at it on a number line, right in the middle, we have mass 32. Right here, we have 31.5. That means that to achieve a total mass of 31.5 on our number line, we have to have much more of 31, less of 33. If we took the average mass of 100 different elements and they get 31.5, more of them are 31 than we have 33. In fact, to get 1/4 of it, of the space to be closer to 31 and 3/4 of that space to be closer to 33, we actually need 75% of the 31 mass. It's kind of more logic than actual anything. The real way to do this is you just take the percent, multiply by the mass, but we'll see that in a later problem. I insert a periodic table so I can refer to it. Going on to number 4. What is the maximum number of electrons that can occupy an s orbital? We said earlier, any orbital can only hold 2. Which of the following is the electron configuration of a neutral nonmetal element? So neutral tells me that there is no charge, meaning that I'm not looking at anything with gained or lost electrons. I can take these and just assume that these refer to any given specific element, and I don't have to worry about these electron configs meaning a different element. Non-metal. Non-metal means if we're looking at our periodic table, we are dealing with this section right here. So basically, we're looking for an element that has an electron configuration within this section of our periodic table. So let's go ahead and look at the individual configurations, and I'm going to throw ahead another periodic table. So moving forward, I'm going to actually move this periodic table. Ne3s2 3p1. So Ne, so we're moving over here, 3s2 3p1. This is referring to aluminum. Ne3s2 3p4. So again, 1 2 1 2 3 4. This is referring to sulfur. We already hit it. We can go to the other ones. Ne3s2 3p6. 3d4, the 3p6 takes us all the way to argon. 4s2 takes care of these, and 3d3 takes us to vanadium. D, 3s2 3p6 3d10 4s2. So same as vanadium, but instead of 3d3, we now go all the way to 10, which is zinc. So this is going to be zinc. All right. Moving on to number 6. How many p orbitals are fully occupied in an aluminum atom? Well, for this, it's actually much easier to do the electron configuration. So once again, I will grab my periodic table, duplicate that, move it over here, and erase a little bit of this shenanigans. Whoops. So I'm going to go ahead and look at aluminum. Aluminum encompasses the 1s2. Here we have 2s2. We're not aluminum yet. Here we have 2p6, still not aluminum. Here we have 4s2, and here we have 4p1. So we're going to keep all this in mind as we move forward. How many p orbitals are fully occupied? 2p6 represents 3 full p orbitals. 4p1 is 1 unfilled orbital. Therefore, my answer is B, 3. All right, moving on to number 7. Which species has one more neutron than electrons? Let's start with the first one, lithium plus. Here I can see that the mass number is 6. The lithium is element 3. We have 3 neutrons. I also have a positive charge, which means I have one less, one less electron. Therefore, I have 2 electrons. Oh, we already found it. Lithium has one more neutron than electrons. All right, there's our answer. What is represented by the plus in 2 plus? Well, the only way to get a positive charge is, or the only way to get any charge is from movement of electrons. Protons can't leave and join, so it's got to be movement of electrons. And if we lose electrons, we gain a positive charge. How are emission spectra formed? Well, when we learned from our line diagrams, we get light when electrons fall from higher energy levels. So photons are emitted when promoted electrons return to a lower energy level. What is the relative atomic mass, AR, of an element with the mass spectrum shown below? Well, I already can tell that there is a lot more of the 25, so our answer is going to be closer to 25, but it's not going to be exactly 25. So with that in mind, chances are it's going to be C, no math involved. If I really worked it out, the percent abundance of mass 25 is 80, so I would do 0.80 times 25 plus, and this is 10, 0.10 for 10% times 23 plus 0.10 times 24, and I would get 24.7. Again, math would actually solve this, but logic makes this one quite a bit easier. What is the ground state electron configuration of an atom of chromium? Z equals 24. That Z purely represents the number of protons, the atomic number. So looking at our periodic table, there really should just be a hotkey for this one, but looking at our periodic table, chromium is right there, following after argon. So we're going to start with argon. And we have the 4s2 filled, 4s2, and 3d4. But this isn't correct. The problem is we learned that the d orbitals are actually very close to energy than the s orbitals. And in this case, we kind of would fill them all at the same time. So if this were the 4s and this 1, 2, 3, 4, 5, well, these, let's use a little bit of a highlighter. So this is the 4s, and these are the 3ds. 3d. We kind of fill our 6 electrons in each one first before we drop down. So it actually becomes 4s1, 3d5. So it's C. Because they're so close in energy level, we can't really double up on the 4s until we fill the 3d orbitals. What is correct for this element right here? It is phosphorus, so we know it has 15 protons. Awesome. We have 34 for our mass number, so 34 minus 15 equals 19. Therefore, we have 19 neutrons, so it cannot be these two down here. And lastly, we have a 2 minus charge, which means we have 2 more electrons, because electrons are negative, so it's got to be B. Which transition in the hydrogen atom emits ultraviolet light? Any drop to n equals 1. So there's only one answer, C. Which statement is correct for the emission spectrum of hydrogen? Lines converge at high frequencies. So if we look at our emission spectrum for hydrogen from before, we saw that we had like one in the red, then green, blue, purple. These are higher frequencies. So one's true. Electron transitions to n equal 2 are responsible for visible. We just had to memorize that. That's true. Lines are produced when electrons move from lower to higher energy levels. We already said before, light comes from the opposite, high to low, not low to high. So it's going to be A. Which statement about cobalt and iron is correct? Now, this one did have an error in the original answer sheet, but we're going to check. Both have the same number of neutrons and electrons. Both have the same number of protons. Both have the same number of neutrons. Both have the same number of protons and neutrons. They can't have the same number of protons because they're different elements. So it cannot be, whoops, it cannot be B. It cannot be D. What about neutrons? Cobalt is element 27, while iron is 26, 27, 26. And so cobalt has a mass number of 56, while iron is 55. Yeah, that actually looks like they have the same number of neutrons. In this case, it is 29 neutrons for each. So they have the same number of neutrons, that's true. And now the charge. Iron has a charge of 2 plus, cobalt has a charge of 3 plus, so that means cobalt in this case has 24 electrons. Oh, and iron also has 24 electrons. A is the correct answer. What is the composition of Si-26? Well, that is silicon, and knowing it's silicon tells me that we should have 14 protons. So it's got to be not A, and it can't be D. But now we know that 26 minus 14 is the number of neutrons, which is 12. 12 neutrons, cool. And then lastly, we have a neutral charge, no charge. That means protons equals electrons. All right, gotta be C. What is the change of state from a gas to liquid? That is called condensation, like condensation on the outside of a glass, where the water in the air cools down and turns into liquid. What quantities are different between the two species? So they're different elements, so they definitely have a different number of protons. And similar to the other answer before, we can look at 208 minus the number of protons in polonium, which is 84, versus 207 minus number of protons in lead, which is 82, we're going to find that in this case, PO is going to have one more neutron with 124 neutrons. Oh, actually, yeah, one less neutron. Well, this has 125 neutrons. So the difference are the protons and neutrons. What is a relative atomic mass sample of argon containing 30% of the AR isotope and 70% of the 37 isotope? So we're going to do 0.30, because it's a percent, times 35 plus 0.70 times 37. And you all get calculators for this, but your number should be closer to 37 because we have more of the 37. So it's going to be C. If we do the math, we still will get 36.4. But again, you can just logic it out. Our number is closer to 37, so we should have something that's at least more than 36. Which diagram represents a homogeneous liquid mixture? So we have two homogeneous solutions. B is a homogeneous gas. D is a homogeneous liquid. I know that because the particles are on the bottom in D while they're floating around in B. Deduce the number of subatomic particles in chlorine. Chlorine is element 17, so it should have 17 protons, can't be B. It has a positive charge, which in actuality, chlorine never is going to have a positive charge. Like there are like no situations where it wants that unless maybe it's bonded to fluorine. But regardless, chlorine has a positive charge, so we should have one less electron. Let me make that look clear. One less electron. So we're going to go to D, the one that has one less electron. All right, sketch the energy level diagram of hydrogen, showing multiple energy levels and diagramming the energy drops. So let's just go ahead and do a rough one. A couple things of note. N equals 1. We have to label these. N equals 2. N equals 3. N equals 4. N equals infinity. We need our axes, which is going to be increasing energy, or just energy is fine. So right there is 2 points, the diagram with the energy levels labeled. And now to get the full credit for our ultraviolet, let's do 3 drops, and that's UV. And let's get all the drops for visible that we can, and that's visible. There you go. The answer for C can be found on the answer sheet, and there is no real explanation needed for that other than the explanation that's already there. Hopefully this helps. Have a good one.